All right, this will be our last homework video of the year on L'Hopital's rule. It'll be not too much different for you guys. I won't see you in class, but homework video is still going to be up for this. And then in our meetings, we'll talk about how we're going to review for the AP test. So anyways, let's just get started with L'Hopital's rule. It could be written like this. You can have an S here, but with L'Hopital's rule, if you ever are trying to evaluate the limit, a limit of, typically it's a quotient, something over something, and you end up with, when plugging in a, whatever it is, 0 over 0, or infinity over infinity, certain instances like that. We call this, indeterminate. It's usually an indication that we have a hole. And back in Unit 1, we were able to find the location of the hole algebraically. But what L'Hopital says is if you, let's change this to f of x and g of x, or just like random functions. And if h of a and g of a is 0 over 0 or infinity over infinity. L'Hopital says to find this limit, you can just look at the derivatives of the two functions and see if you can evaluate these at a. And typically you will be able to after one derivative, but sometimes you won't be able to. If this is 0 over 0 again, then you're just going to go and continue to take derivatives, take the second derivative. It's a way that we can compare growth rates. It's the way that we can answer the questions that we talked about at the beginning of the year, which is like growth rates of x to a very large power versus like an exponential function, e to the x. So that's L'Hopital's rule. What's important is that it's not the quotient rule. This is different than the quotient rule. If I asked you to just take the derivative of h over g, the derivative of h over g would be h prime g minus g prime h over g squared. This would be the derivative of h over g. That's not what L'Hopital's rule is. L'Hopital says, actually look at tangent slopes at locations, and it'll be the same. It's kind of dealing with the linearization we talk about in the notes, the linearization of the function as you zoom in a lot, and you're just looking at a limit. You're just looking at one specific point. We can just look at tangent lines and more specifically tangent slopes. All right, enough intro. Let's get into it. If I'm trying to find the limit as h approaches 0, the first thing I should do is find the function at 0. Sometimes this will work, and you will get a number or 0 over a number. And if you ever get 0 over a number, your answer is 0. If you get a number, your answer is a number. But here in this situation, I get 0 over 0, which means I will be applying L'Hopital's rule, which means I'll take the derivative. The derivative of e to the 3h would be e to the 3h times 3. The derivative of 1 is 0. It's very important that when you take the derivative of a constant, you remember 0. The derivative of the denominator is 2. We will then plug in 0. I get e to the 0 times 3. That's 3 divided by 2, 3/2. This guy, I plug in 1. And here's a great example of like, don't have to use L'Hopital's every time. You should check. If I plugged in 1, I get 2/3. This is the answer. No L'Hopital's needed. There was a free response question last year where students thought they had to use L'Hopital's rule, but turns out it wasn't needed. Most of these other examples, we will need it. For example, if I plug in 0 here, I get 0 squared, which is 0. I got cosine of 0 minus 1. That's going to be 0 over 0. So I'm going to use L'Hopital's rule. Take the derivative, I get 2 theta over, this will end up being negative sine 3 theta times 3 minus 0. The derivative of 1 is 0. I find this limit as h approaches 0. I plug in 0, I get 0 over, okay, hold on a second. I get 0 minus 0. This is 0 over 0 again. Don't worry, use L'Hopital's again. You'll find the limit as h approaches 0 of the derivative of 2 theta will just be 2. We're taking it with respect to, sorry, this should be theta. This should be theta. And then the derivative of negative sine 3 theta will be negative cosine 3 theta times 3, that's 9. This stays as a 0. I plug in 0 to this, I get 2 over cosine of 0 is 1. I have a negative, I have a 9, I have negative 2/9 as my answer. This will be another situation where you have to take the derivative twice. If I plug in 0, 0 over 0, I'm going to use L'Hopital's rule. Take the derivative of sine, I get cosine. Take the derivative of t squared, I get 2t. The limit as t approaches 0. Plug in 0, I get, oh, this is interesting. Plug in 0, I get 1 over 0. Now, this is not 0 over 0. This is undefined. This means that this actually has a, this is an indication of a vertical asymptote. Remember, we talk about like a number divided by something approaching 0, whether to the left or to the right. This is going to be approaching a positive or a negative infinity. So this actually does not exist. There will be a vertical asymptote. You typically won't see things like this on the AP tests. We can go ahead and just kind of visually see some of our answers to these, make sure they're correct. Let's pick this guy first. Hope we're comfortable with going online to either Desmos or to our TI-83 Plus emulator, which will be available to us. We'll be able to use that for our AP exam, which will be online. So we're looking around 0. So I think the answer is negative 2/9. I'm going to get really, really close to 0. I see there's a hole at 0, but we see that we are approaching the hole from both sides if we recall limits. I'll go just to the right of the hole. And I see I got negative 0.222, and that's the same as negative 2/9, 0.22222. Okay, so, but the other one, sine t over t squared, you see at 0 there's a vertical asymptote, so that's why it doesn't exist. There's not like a hole. Okay, let's try this one. Plug in 1, I get e minus e over 5 log 1. E minus e is 0, log of 1 is 0. This is 0 over 0. I'm going to use L'Hopital's rule. The derivative of e to the x is e to the x. The derivative of e is 0. I'm going to write that down just so you remember. E is a constant. E is just a number. E to the x, that's a function. E to the x's derivative is e to the x. E is just a number. Its derivative is 0. 5 log x, its derivative would be 5 over x. I'll find this limit as x approaches 1 by plugging in 1. I get e over 5. That's my answer. Let's look at this one. I'll plug in 1. I get log 1 minus 1 plus 1. That's 0 minus 1 plus 1, so that's 0. Plug in 1, I get 1 minus 2 plus 1. That's going to be 0. So I'm ready to use L'Hopital's rule, which says take the derivative of the top and bottom separately. This is not the quotient rule. This is different. On the limit as t approaches 1. And I get 0 over 0. Oh, got to use L'Hopital's rule again. Derivative of 1 over t. What's that? Well, let's remember 1 over t can be written as t to the negative first. You could use the quotient rule here, but it's better to rewrite it and then use the power rule, bring it down, give me a negative power. The derivative of 2t minus 2 is just going to be 2. I'm now ready to plug in 1. I'll have Negative 1 over 1 squared over 2, so that's negative 1/2. Let's just double check, just to show you, like the situation, log t minus t plus 1. This is all being divided by t squared minus 2t plus 1. I'm thinking that at 1, we're going to see there's no value, but we can see we're approaching it to the left and to the right. I'll go just to the right of 1 or just to the left of 1, and I'm going to see it's going to be very close to 0, but that's not correct. There you go, close to negative 1/2. There you go, closer to negative 1/2. There you go, pretty much right on. All right, we can use trig functions other than sine and cosine. Secant, the secant of pi over 2. What's the tangent of pi over 2? Secant's the reciprocal of cosine. Cosine of pi over 2 is 0. But this is 1 over 0. It's not that it's 0, it's that this is undefined. Meanwhile, tangent of pi over 2 is sine over cosine. That's going to be 0. So this is not 0. This is undefined. I think we have a situation I don't know what situation we have here. I've never seen something like this. Let's just take the derivative, see what happens. I get secant x tangent x. If you remember the derivative of secant, I get secant squared. A limit as x approaches pi over 2. Again, secant of pi over 2 is just going to be undefined. So I get undefined over undefined. I really feel like this is not one that we'll be able to answer. If I'm wrong, strike me down. Let's see. 1 over cosine x divided by tan x. You won't see something like this on your quiz. Maybe pi over 2. Oops. Let's go pi over 2 plus. Oh, there is an answer. It looks like it's going to be close to 1. I guess they want us to take the derivative again. Oh my gosh. Oh my goodness. I was wrong. I was wrong. Oh, wrong. L'Hopital's rule doesn't work here, but simplifying does. You can see that this is, you're not going to see something like this on a quiz. This is something where simplification helps, but derivatives don't. If I do simplify, I am finding the location of the whole is at 1. Don't worry about this one. Especially for your AP test. This one definitely does work, I believe. I think we'll have to take the derivative twice. Plug in pi, I get 0 over 1 minus cosine pi. 1 minus the cosine of pi is negative 1. This is 0 over 2. This is 0. This has a value. This is my answer. No L'Hopital's needed. Okay, couple more. Oh, sweet. 2 to the t. I saw on the practice AP test that you had to take the derivative of something like this. So it's important to remember it. The derivative, well, let's plug in 0 first. I got 2 to the 0 minus e to the 0, which is 1 minus 1. then over 0. Okay, so that's 0 over 0. Use L'Hopital's rule. Derivative 2 to the t is 2 to the t log 2. Derivative of e to the t is e to the t. Derivative of t is 1. We'll find the limit as t approaches 0 of this. I get 2 to the 0 log 2 minus e to the 0. So this will be log 2 minus 1. You can check that with your calculator. Limit as x approaches 1, log x over sine pi x. I plug in 1, it's 0 over 0. So I'm going to use L'Hopital's rule, 1 over x over cos pi x times pi. It's very important that you show this step. If you do not show that you can use L'Hopital's rule, you won't get full points on a free response question. So make sure you show the 0 over 0. So maybe I should probably even write in log 1 over sine of pi. That way they know that I've been plugging in 1 to get 0 over 0. I don't just assume. Limit as x approaches 1, I'll get 1 over the cosine of pi is negative 1. So this will be negative pi. That'll be my answer. All right, some infinities. These are good ones. Probably would start off by writing this as x squared e to the x. Now, the question is like, what grows faster, x squared or e to the x? And you were told that these exponential growth functions, and we kind of just did a numerical example, grow faster than x to any power. But we didn't really investigate, and L'Hopital's rule kind of shows the investigation. It allows you to compare growth rates to tell which one goes to infinity quicker. And this is what we did in our notes, which you watched, obviously. So if I plug in infinity, I get infinity over infinity. That doesn't mean the answer is infinity. It doesn't mean it's 0. It means I have to do some more investigation. Well, in the past, you immediately would have said, okay, this is 0 because you did slower growth over faster growth. And if you think about fractions where the numerator is growing slower, like adding 1, versus a denominator, multiplying by 10 is a faster growing thing than adding 1. You can see that these fractions 1, 0.2, 0.03, 0.004, they're getting closer and closer to 0. So that's one way. The other way is now saying, well, let's look at the growth rates. I got 2x over e to the x. That's the derivatives. Growth rates are derivatives. Well, if I plug in infinity, I still get infinity over infinity. But if I go one extra step, and I take the derivative again, I get 2 over e to the x. Well, 2 is not growing at all. E to the x is growing. You have a constant divided by infinity. This is definitely approaching 0. So you know for certain that it's actually slower over faster. X to any power will eventually get down to a number or 0 versus a number to a power. Its derivatives will always be the number to the power. This is the same way. We know that if you're plugging in infinity, this doesn't matter, this doesn't matter. You can easily say you got 3x over 4x. Well, that's just ending up to be 3/4. This is only when we're plugging in very, very large numbers. But using L'Hopital's rule, you see that you'd have infinity over infinity. You would take the derivatives to look at relative growth rates, and you'd see this is growing at a rate of 3 y's per x. This is going at a rate of 4. The 17's gone because it's the derivative 0. The 11's gone, its derivative 0. So that's another way to get 3/4. So 2 different ways. Couple more. We were told that log x is the slowest growing function versus the cube root of x, which is x to a power, which is going to grow faster than the log of x. But let's say you didn't know that. Let's say you didn't know that it's going to be slower over faster. And we already showed slower over faster is approaching 0. You would use L'Hopital's rule because this would be infinity over infinity. And you'd say, okay, 1 over x, the derivative of x to 1/3 is 1/3 x to the negative 2/3. Limit as x approaches infinity. Okay, well, this is going to be 1 over infinity. That's going to be approaching 0. This will be approaching 0. Man, how can you do this with L'Hopital's rule? Let's see. Watch this. I can go 1 over x. This is 1 over 3x to the 2/3. I'm going to simplify this. This is 1 over x times 3x to the 2/3 over 1. You could simplify this. Remember when you're dividing, you subtract. I'd end up with more x's in the denominator, which is why I have x squared in the denominator. Well, 2/3 and then 1 minus 2/3 is going to be 1/3. So this is 3 over x to the 1/3. If I plug in infinity, I can see this is going to be 0. So actually, L'Hopital's rule is more difficult than just remembering your growth rates and understanding fractions where you have slower growth over faster growth. This is great though. Comparing logs, like log of x squared, is that growing the same as the log of x? Is it growing differently? If I had like, maybe it's like same growth over same growth. Maybe you think that the growths cancel and you have 1/3 as the answer. This is where L'Hopital's rule actually really helps with log functions. So if I plug infinity, I see I get infinity over infinity. I'm going to use L'Hopital's rule. Watch the derivative. Derivative of log x squared is 1 over x squared times 2x. Using the chain rule, let's remember the chain rule. Outside's inside. The outside is the log function. The inside is x squared. The derivative of the log function 1 over. The derivative of x squared 2x. So that's how I get 1 over x squared times 2x. That's a quick little reminder. That's divided by 3 times 1 over x, or 3 over x. 2x over x squared simplifies to be 2 over x. This is 3 over x. This can be simplified to be 2 over x times x over 3. These cancel. It turns out my answer to this is 2/3. So it ends up having to do something with this exponent as well as the constant in front. It's kind of how like logs undo exponents. That's kind of one way to think about why the 2 has to come into play, which is really interesting. Also, you can think about how with log properties, you have a constant times the log of a number. You can write this as log of, oh yeah, you can actually write this as 2 log x, and this is 3 log x, and those cancel, and that's 2/3. That's using log properties, because the log of, x to a power is p times the log of x. I didn't even actually think about that in the past, but now we got it. Cool. So like, this is a little tougher because I could use log properties. I'll show you log properties after it. But let's use L'Hopital's rule. We'll get infinity over infinity. What's going on with growth rates? Well, derivative of log ax plus b. Well, a and b are constants, so I'd have 1 over ax plus b times derivative of ax plus b would just be a, if you think about a as a number. And then over, this is 1 over cx squared plus d times 2cx. Seems really tricky. Let's see. I got a over ax plus b. I'm going to go ahead and simplify. We've noticed with a couple of these, simplifying is what you need to do after your first step of taking the derivative. This turns into acx squared plus ad over, I'll multiply the 2cx in, 2acx squared plus 2bcx. And you're looking at the limit as x approaches infinity. Now, you could continue to use L'Hopital's rule, but you could also now use kind of your understanding of properties and growth rates. The AD is growing faster. The AD is not growing at all compared to the ACX squared. The 2BCX is not growing as fast as the 2ACX squared. So you end up with ACX squared over 2ACX squared. The x squareds cancel, the a's cancel, the c's cancel. Your answer is 1/2. Okay, that's one way to do it. What would be the other way to do it? Here's the other way. I don't like this. I'd rather you focus on using the L'Hopital's rule, but I'll show you. You've got ax plus b, and then cx squared plus d. If you're plugging infinity, you immediately know that the b doesn't matter and the d doesn't matter. So log ax over log cx squared. Well, there's a product here, and using log properties, you can write this as log x plus log a, and this is log x squared plus log c. And you can then write this as log x plus log a over, using a log property, this is 2 log x plus log c. If you are looking at the limit as x approaches infinity, this doesn't matter, that doesn't matter. These are growing the same, they just cancel. That's another way to get 1/2. That's a tricky one. Both ways are tricky. So, I don't know. Go with it. Pick away. So again, L'Hopital's rule. First, you confirm infinity over infinity. I'd have 1 over x cubed times 3x squared. I'd have 1 over x squared times 2x. These are the chain rules of logs of log as the outside, the inside being x cubed. You're looking at the limit as x approaches infinity. This simplifies to be 3 over x. This is 2 over x. This will simplify to just be 3/2. Using log properties, you can write this as 3 log x. You can write this as 2 log x. Cancel, cancel. There's 3x. All right, from last year's free response questions, here we go. Functions f, g, and h are twice differentiable. G of 2 equals h of 2 equals 4. This is a tough question. I just remember this right off the bat. The line y equals 4 plus 2/3 x minus 2 is tangent to both the graph of g and graph of h at 2. All right, well, that means g prime of 2 equals h prime of 2, which equals, if this is a tangent line at the point 2, 4, the slope's got to be 2/3. We're going to have to use that. You need to be able to know that. Why did I say that? You know, tangent line y equals y minus y1 equals m times x minus x1. Here's my m. The function h satisfies h of x equals x squared minus 4 over 1 minus f of x cubed for x doesn't equal to 2. It is known that the limit as h approaches 2 can be evaluated using L'Hopital's rule. Use the limit as h approaches 2 of x, h of x to find f of 2 and f prime of 2. Show the work that leads to your answer. So we have no information about f besides like f is in here. Here's your key. We are told that the limit as x approaches 2 of this can be found using L'Hopital's rule. Well, that means if I plug in 2 squared minus 4, yep, that's 0. Well, that means the 1 minus f of 2 cubed also has to equal 0. Okay, cool. So that means 1 minus f of 2 cubed has to equal 0. F of 2 cubed has to equal 1. Subtract 1, divide by -1, or just add the f of 2 cubed. Cube root it. F of 2 has to equal 1. Okay, good. So for the question, I've already found f of 2. Now, what is f prime of 2? Well, I know h prime of 2 is 2/3. I know f of 2 is 1. So I don't know what the limit is. I know I can evaluate it, but I know the derivative. Here is a nice little thing here where I know h prime of 2 equals 2/3. And I know what h prime of x is because I can take the derivative of h. You have to use the quotient rule, though. This is like a nice little fake out, oh, take the derivative of the top and the bottom. No. H prime of x is the derivative of this. I have to use the quotient rule. The derivative of the top times the bottom is going to be messy, but stay with me. Minus the derivative of the bottom. Okay. Chain rule for the bottom. The outside is the cube. The inside is f of x. So the derivative of the outside is 3 stuff squared. The derivative of the inside is f prime of x. So the derivative of the bottom would be, this negative has to be in play too. So that'd be negative 3 f of x squared times f prime of x. That's times the top, x squared minus 4, all over the bottom squared. This is phenomenal. But watch, it won't be that bad. 1 minus f of x cubed squared. I'm already thinking ahead. And I'm thinking, I might not be doing this the right way. Because f of 2 is 1. And if I plug in 2 in for x to find h prime, this will end up being 0. What am I missing here? Well, h prime of 2 is 0 over 0. This is tricky. So that means I actually have to use L'Hopital's rule to find h prime. I think that's what it means. I feel like I now should be taking the derivative of the bottom and the top separately. I don't think that's right, though. I did this. I'm sorry. I'm going to have to look back at how I did this. Oh. Yep, I went the wrong way. I was focusing so much on the derivative, but the derivative is not the way to go. I got that, but h of 2 is 4. Since h of 2 is 4, that means the limit as x approaches 2 of h of x, since the function is continuous, has to equal 4. You plug in 2, you get 0 over 0 because you now know f of 2 was 1. Now we use L'Hopital's rule. We take the derivative of the top and the derivative of the bottom. We already took the derivative of this. This is going to be 3 f of x squared times that equals 4. We get the limit as x approaches 2. Plug in 2, I get 4 over 1 minus 3 times f of 2 I found was 1. F prime of 2 I'm trying to find. This has to equal 4. So get 4 over 1 minus 3 f prime of 2 equals 4. Divide by 4, flip both sides. 1 minus 3 f prime of 2 has to equal 1. Subtract 1, divide by negative 3. F prime of 2 has to equal 1/3. Is that what I got? That must have been what I got. This is a tricky problem. Last year's free response is really hard. You guys don't have to worry about that. You guys are just going to be taking one free response test for 45 minutes, and it's going to be 3 questions. And that's your AP exam score. Whew! But you get to do it online. I don't know if that's good or bad. We'll talk more about that. Kind of crazy what you guys are going through. But yeah, that's the situation we're in. Let g be a differentiable function so that g of pi over 2 is 0. Graph of g prime is shown. Find the value of the limit as x approaches pi over 2, or state that it does not exist. Justify your answer. So this is a great example. If I plug in pi over 2, like, don't just use L'Hopital's rule right away. Confirm that you'll get 0 over 0. Okay, so I get e to the pi over 2 cos pi over 2 over 0. 0 over 0. Now I can say I'm going to use L'Hopital's rule. Okay, so that means f prime, g prime. Limit as x approaches pi over 2. F prime is e to the x, derivative of the first times the second, plus the derivative of the second times the first, all over g prime of pi over 2. Here's g prime. What's g prime of pi over 2? It's 2, right? If this is the graph of g prime, I don't have to look at the slope. I'm just like g prime at pi over 2. That value is 2. And now, if I plug in pi over 2 to the numerator, cosine of pi over 2 is 0. Sine of pi over 2 is 1. So this is be negative 1 e to the pi over 2. My answer would be negative e to the pi over 2 over 2. Cool? H of x equals g of x over f of x. Find h prime of 1. Okay, so this is like, oh, okay, I have to take the derivative. A lot of people think, oh, h prime. I've done L'Hopital's a bunch. It's going to be g prime over f prime. Wrong, 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 wrong. If you're asked to just take a derivative, this is not a limit. This is not a limit question. You were asked to just take the derivative. So when you take the derivative, you have to use the quotient rule. The derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. They also try to trick you by putting f on the bottom. A lot of people memorize like the f's and the g's. You won't do that. Find h prime of 1. G prime of 1 is 8. F of 1 is negative 6. Great. Thanks, guys. F prime of 1 is 3. G of 1 is 2 over f of 1 squared. This is a free response question. You can leave it like this, right? So I don't know what you guys are going to do for your free response questions. I think you have to like write your answers on a piece of paper, then take a picture and send it in like the time provided. Oof, who knows? We'll find out more as we get closer. But you won't be taking it in school. All right, the last ones. Evaluate the limit. We're looking for this limit, and I got an integral. It's an accumulation function. You will need to know this moving forward, but it's actually not going to be tested on you guys this year. The accumulation function is dropped from the AB exam, but if you're taking the BC test, it's not dropped. Well, first thing is if I plugged in 0, I have an integral from 0 to 0. I know that no matter what f of x is, that's going to be 0. So this is 0 over 0. So I'm going to use L'Hopital's rule. You got to remember with an accumulation function that the derivative of an integral is just, this should be f of t. This is my bad. You can't have the same variables. My bad. Anyways, the derivative of the integral is just whatever's inside with x's. So I got f of x over 3x squared. Limit as x approaches 0. Plug in 0, I get f of 0. Oh, f of 0 is 0. Plug in 0, I get 3x squared, that's 0. Use L'Hopital's again. I get f prime. I get 6x. Plug in 0. On the limit as x approaches 0. F prime of 0 is 0. 6 times 0 is 0. Use L'Hopital's rule again. Limit as x approaches 0 of f double prime of x over 6. So definitely going to see something like this on your quiz. F double prime of x at 0 is 3. Divided by 6, get 1/2. X approaches 2. Well, this doesn't work. I tried to make something that's nice, but this one doesn't work. Because if I plugged in 2, again, this is supposed to be t, this is supposed to be t. It would give me 0 minus 6 over 0. That's a number over 0. That means I have a vertical asymptote. I'm leading you to have to take derivatives and go from there, but it doesn't work for this one. All right, a couple more. F of 5 minus 5 over 0. F of 5 is 5. So this is 0 over 0. I'm going to use L'Hopital's rule. I get f prime of x minus 1 over 2x minus 5 times 1. That's the derivative of the inside. Limit as x approaches 5. F prime of 5 is 1. Uh-oh. F plug in 5, I get 1 again. I get 0. Got to use L'Hopital's rule again. You'll see with these types of problems, these are more common problems that you're going to see on the AP exam. So if I take the derivative again, I get f double prime of x. The derivative of 1 is 0. I just get 2. F double prime at 5 is negative 1. Same deal here. If I plug in 5, I'll get 0 over 0. I'm going to use L'Hopital's rule. Derivative of 5 is 0. I get just f prime, negative f prime. I get cosine pi x times pi. Plug in 5. F prime of 5 is 1. Cosine of 5 pi. So 5 pi is going to be over there on the left. So 1, 2, 3, 4, 5 pi. It's an odd pi. So it's going to be a negative value. So this is going to be negative 1 over negative pi, which is 1 over pi. It's a good question. Oh, this is a good one. E to the f of x. Plug in 5. E to the f of 5 is, f of 5 is 5. So if I plug in 5, I get e to the 5 minus e to the 5 over negative 5 plus 5. So that's 0 over 0. I'm going to use L'Hopital's rule. Got to show you chain rule for this one. E to the power is the outside. F of x is the power. The derivative of this is e to the f of x times f prime of x. A lot of people forget the f prime of x. That's the derivative of the top because the number e to the 5th is just a number. Its derivative is 0. And then divide that by 1. Well, the limit as x approaches 5. E to the f of 5. F of 5 is 5. So this is e to the 5th times f prime of 5 is 1. So the answer is e to the 5th. You may see a question similar to this. Oh, this is fine. On your test. I really feel like we're going to see a differential equation on your test. We're not going to see an accumulation function. We're not going to probably see a straight line motion problem because they got rid of distance and displacement. They got rid of average values. So I'm thinking table, I'm thinking differential equation, and I'm thinking a function analysis with f prime. So here's a differential equation. We're not going to be able to solve this, but we could answer this question. Well, the limit as x approaches 5. I plug in 5, I get 0. I see f of 5 is 0. So L'Hopital's rule. At the derivative of the top, the derivative of the bottom, that's f prime of x. Find the limit as x approaches 5. Okay, I need to find f prime of 5. Well, dy dx is considered like the derivative. Here's the derivative, 2x plus y. Well, here's the point x, y, 5, 0. So I would plug in 5 in for x, 0 for y, I get 10. So f prime of 5 ends up being 10. So that's like f prime of 5 is the same as dy dx at 5, 0. And that's 10. So my answer is 3/10. Well, I just found f prime. Oh, this is a great question. Mr. Huffaker put this question together. It's a great question. So I already found f prime of 5. It's 10. So I know that if we start here, I get 0 over 0. I got to use L'Hopital's rule. Beautiful question, because now I got to take the derivative of the top. And watch how we're going to have to do this. Double prime of x over 1. What is f double prime of 5 is really my question, because it's divided by 1. Well, I have to take the second derivative, d squared y over dx squared. The derivative of 2x is 2. The derivative of y is not 1, it's dy dx. Remember, implicit derivatives, derivative with respect to x of a y is a dy dx. Now, if I find d squared y over dx squared at the point 5, 0, that's f double prime of 5. That's 2 plus, I already found this was 10. This is 12. The answer is negative 12. What a great question. All right, so there's your L'Hopital's rule homework. You're definitely going to see a L'Hopital's rule on your free response test. I guarantee it. It's just like, it's always something easy that they can ask. We will be prepared for it. You're not going to probably see something like this from the first 2 pages. You will see it on your quiz. You'll see something more like the last 2 pages or the last 3 pages in terms of what the question type you'll see. So we'll prepare you for it, and you're going to be ready for your quiz. I'll figure out how I'm going to assign your quiz. It might be a similar situation to free response tests where you like have 45 minutes and then you need to submit it to me over some sort of method at the end of the 45 minutes. Or maybe I'll give you an hour or something and let you work with a neighbor if you want to. But that'll all be done through Schoology. We'll figure it out. I'll have to grade it myself. That's exciting. But whatever. All right. Take care out there. We'll see you online.